we have another session. Bahram Banisadr is working as a product manager for Azure messaging in Microsoft. It's been a part of Microsoft for the past 2.5 years, and messaging services are inevitable from the ages, isn't it? So, how many of you are eagerly waiting for the updates from the event grids? Yeah. Let's hear from what Abraham about the capabilities of event grids and event patterns. I welcome Bram. Thank you.
Thanks, Shiva. Welcome, everyone. Yeah, as Shiva said, my name is Bahram Banisadr. I work on the Azure messaging team under Dan, who you saw speak yesterday. And I'm the PM for Event Grid. And I've actually been lucky enough to be part of the team since Event Grid was just an idea. And we've gotten to see it evolve quite a bit. So we actually, this past week, launched a whole bunch of updates. So I'm going to give you a walkthrough of some of those updates, but I'm also going to give you a little bit of an idea of one of the most common questions we get is when should you be using Event Grid versus other services within our messaging portfolio. And then I'm also going to try and give you a little bit of an idea of our vision for where we want to be going, as well as clear up a little bit of, give you guys some idea of the way we look at one of our more confusing features called an event domain, and kind of where we see it to be useful through a case study. So to get started, when would you want to use Event Grid? So at the end of the day, you kind of got to get down to your basics when you are looking at any of the messaging services, and Event Grid is a pub sub system. That means that its primary purpose is to broadcast events. So you have events that are generally in the past tense, and they are talking about something that has happened rather than a you should do this sort of statement. So event grid has event sources, and these sources create events. These are, they put events on topics within event grid, and this is for the purpose of broadcasting. And event sources generally don't care about who's listening. So they are loosely coupled in that way. They're just saying, hey, I'm an actor in the system and this has occurred, and anyone that's interested, come subscribe. Or anyone who's authorized to listen, come subscribe. On the other end of things, we have event handlers or syncs. And these are actually by necessity aware of the publisher. And they need to be aware of the publisher because they are responsible for reacting to the events. So they need to know the types of events they're going to expect on the topic, the volume, the event size in theory, and they need to be prepared to handle those events. So you kind of have almost an asynchronous nature in the coupling of the source and the sync. And it's a one-to-many relation. Event Grid is not a request-response system, nor is it a log. So as you saw Dan and Ashish talk about yesterday, we have Service Bus and Event Hubs for those purposes. However, Event Grid can play a role in both request-response systems and logging systems, things like Service Bus and Event Hubs. And we'll talk a little bit about where it's useful in those systems later. So I know you're all probably relatively familiar at this point with what Event Grid is. We've kind of beat you all over the head with it until we're blue in the lungs, but I do love blue in the face. I love showing this slide because when we announced Event Grid a little bit over a year and a half ago, if you remember looking at this at all, the number of event sources we had here on the left was a lot smaller list, as was the number of built-in event handlers. And we did talk about a vision where every part of Azure would be interconnected using Event Grid, where any major Azure service would be able to act as an event source and put events on a system topic that you could subscribe to and react to natively. And we are actually moving towards that vision quite rapidly. We've added things like Azure Maps, new types of IoT events as sources. We have more in the pipeline. And we just actually recently added Service Bus as an event handler as well. So with that, what is new in Event Grid today? So the first thing that we recently public previewed is Service Bus as an event handler. And at first glance, this is might seem a bit odd because we already had Azure Storage Queues as an event handler built in. And so you have two queuing systems now. What's the point in that? But the way we think about it is the service bus storage queues were there in case you wanted to pull your events rather than have them pushed to you in Event Grid, and that kind of depends on your your design specifications for your application. If you have something that's continuously sending events to you on a regular rhythm, it doesn't always make sense to necessarily need to build a system where you're having events pushed to you. If you can regularly pull and there's always a queue and the queue is at a certain length all the time, why not just pull the events at your regular rhythm? The reason we've added Service Bus as an event handler is for those request response command and control sort of scenarios. As you all know, Service Bus is really powerful and has a lot of features in it that a standard storage queue does not have for those purposes. So what we were thinking here is the thinking is that Service Bus queues can now basically ingest natively the events that the Azure platform itself is publishing. So just to give you an idea, some scenarios that are possible now, you could have a Service Bus queue, for example, ingest events from Azure Maps, and then you could create a checkout free shopping sort of experience that needs that sort of tight checkout experience where you need to have a transactional sort of semantics there. Or you could do something like have Service Bus queues ingest blob created events and do something like check processing as images of checks are dropped into there. So the idea here is not that you couldn't do these things already with Service Bus, but that you now have native integration with the platform directly into Service Bus in kind of a click and browse sort of manner, making it a lot easier to get up and running. One thing to note is that currently we only support Service Bus queues. So we would love for you guys to test this out and give us your feedback and see what you all think. The next thing that we recently previewed is support for up to 1 megabyte events. And this one also might seem a little bit counterintuitive. I know a lot of the times I've used the verbiage of event and notification kind of interchangeably, and so there is a thinking out there that Event Grid is a notification service, and it is, but when we say notification, I don't mean like a toast notification on your phone. When we talk about notification in Event Grid, I really mean an event, and that means that it should have the full context in it. So when you are sending an event and you are building a pattern in Event Grid where every event you're getting, the first thing you do is a GET request on whatever resource originated the event or whatever resource it's notifying you about to get more context, that is a broken pattern. You should be sending enough context for the event handler to actually begin processing or at least make a decision about what it wants to do. This is still not a file transfer, so if you're dropping something in a storage, you're not trying to send an entire file along. But for example, if you have something like an IoT device configuration change, the best pattern is to send the entire config change in the event within reason so that the downstream handler can begin processing. So as far as pricing for 1 megabyte events, any event over 64 kilobytes that's sent to Event Grid is charged in 64 KB chunks. And the way GA and preview is kind of separated out is just anything that is sent to Event Grid under 64 KB is still handled under our GA SLA. And everything sent, any event over 64 kilobytes is under a preview SLA. So the next thing that we recently announced is IoT Hub device telemetry events. And this is actually one of the things that I'm most excited about. We've been working pretty hard on this with the IoT Hub team for well over half a year now, maybe the better part of a year. And what this is all data flowing through your IoT hub in Azure is now accessible within Event Grid. So you're always able to go subscribe and pull off of the Event Hub within the IoT hub using event processor host. But now you can also subscribe to those events and filter them and have them sent to any Event Grid destination on a push basis. So what this means is it's not replacing using the event processor host pattern on your IoT hub. It's adding to that, because the event subscriptions within an IoT hub are actually connected to routes, if you're familiar with those, in your IoT hub. Those allow you to have pretty robust regex and querying semantics, and then on top of that you can create 500 event subscriptions per IoT hub and have specific filters for each. So you can do something with our advanced filters like, if temperature is over certain value, then I want to route this event, otherwise ignore all events within this particular IoT hub. So the possibilities here are actually nearly limitless, and it's one of the first places where we've actually tapped in directly to the data stream of an Azure service and made those available via Event Grid. The next thing, and it's a pretty big one, is GeoDR, and we're actually going straight to GA with this because we've enabled it across all services, all event subscriptions and topics. So GeoDR on Event Grid is actually, if you have anything provisioned in Event Grid today, you already have GeoDR as of now, which is pretty exciting for us. It's no additional charge, so it is a metadata DR. So what that means is we're not replicating the data flowing through, but just the event subscriptions and topics within your given region, and we're replicating those with a paired region. So what we're doing is anytime you create a new any new entity within Event Grid, we instantly replicate it through a paired region, and then all your traffic is flowing through an Azure Traffic Manager profile. And so if a region becomes unhealthy or goes down, we will automatically fail over the traffic to the paired region and continue flowing your traffic. So when we talk about disaster recovery, the two things that you really care about are your recovery point objective and your recovery time objective. Those are the things that you want to build against. And those are actually slightly different for our metadata and our data within GeoDR. So the first thing is our metadata recovery point objective, and that's actually 0 minutes. So what we're saying here is in any regional failure or outage, all of your existing topics and subscriptions are always going to be safe. You will have 0 minutes of lost data on your control plane. As far as your recovery time objective goes, we're aiming for about 60 minutes, and that's about how long it'll take before new CRUD operations, so new creates and deletes on topics and subscriptions, will start getting accepted. Generally, it happens a lot quicker than that, but if you are planning your business disaster recovery operations model, we're kind of putting 60 minutes out there as the number to kind of plan around. As far as data DR, because Event Grid is on a push basis, pushing as quickly as possible to your endpoints, if your system is healthy, we give an RPO to plan around of about 5 minutes. The reason there's an asterisk there is it kind of depends on how your system is performing at the time of failure. So what I mean by that is if you have, because we're not replicating your data between regions, if you have an outage on your end, so let's say your event handler goes down or it's not keeping up and we're having to retry events and we have 20 minutes of backlog that we're retrying through your system, then you'll have 20 minutes of data that is kind of in limbo in that downed region. Whereas if you're fully healthy and you're fully caught up, you might actually have an RPO of 0. So that's one that's kind of more in your hands, and something to just consider based on what your average failure rate or net, how often you rely on the retry policy within Event Grid. That data, in most cases, once the failed over region comes back online, should be recovered. But again, it depends on what the failure mode is. Obviously, in a smoking hole scenario where the region's, falls off the face of the earth, your data's gone. We haven't replicated it. And then the final thing is your recovery time objective. Similar to your metadata, we're putting 60 minutes out there for you to plan around. So that basically means if there's a regional failover and we automatically failover for you, when will we start accepting new traffic? The number to plan around there is 60 minutes. That said, in our practice scenarios, it's gone a lot faster. We actually, Kishore, the engineer who built our DR system, did a live demo in front of the Azure messaging engineering team at our internal all hands. And he actually, much to my chagrin, brought down a live production cluster in front of everyone on stage. It wasn't a public cluster, so nothing that any of your data would be on, but he set up a heartbeat event going once per second on his command line. You could see it going, and then he just brought down the cluster, and everyone's breath kind of went silent for about 90 seconds, and then all of a sudden, the event started flowing again. Which was actually very thrilling. It was, so it works a lot faster than that usually, but if you're planning around, there we go. If you're planning around that for your business recovery plan, 60 minutes is the SLA we're putting out there. Right. Interesting. Anyway, so last thing to note is, so this is, on the spectrum of control, we're on the complete opposite end of what Service Bus is implemented. So Service Bus allows you to configure a lot of, gives you several knobs and dials to configure your failover, and allows you to actually manually initiate your failover. We are doing this all for free, transparently, automatically in the background, which means that for probably 90 some odd percent of you, you just get a bunch of reassurances for free, and it's really awesome. For those of you that these reassurances are, that you need specific RTO and RPO requirements, we do actually have a health API, and you can implement client-side failover instead of server-side failover. So every topic has a WAC API, WAC health endpoint that you can do a GET request on, and it'll tell you whether or not that topic is healthy and working properly. And so it allows you to very easily actually set up your own client-side failover in the scenarios in which you need, let's say, a data RPO of 0 or an RTO of 0. So the next thing that we published this past week was GA of our advanced filters. So the big update that we made in GAing advanced filters is we now allow you to do your filters on as many layers of nested objects within your JSON payload that you want. So originally, this value here, your key, could only go up to data.key1. Now you can do as many nested objects as you want. And we still have, and for those that haven't used it much, we have filters on numerical filters, Boolean and string operators of all sorts. I believe you can have up to 5 different filters, each with 5 different values on any given event subscription. And one thing to keep in mind is the and/or semantics. So within a set of advanced filters, within a given operator, multiple values there, such as container 1 and container 2 as the values for string contains and subject. That's an or operator. And then between 2 different filters, so we have the number greater than or equals to, and so between these 2 operators, that is going to be an and operator. So it must have both a etc. key 3 value greater than key than 5, and the subject must contain either container 1 or container 2, if that makes sense. Damn you. Right. So the next thing is that we also we just GA'd event domains, and this is a feature that we're both very proud of, and is also a little bit of a thorn in my side because, to my knowledge, it's a one-of-a-kind feature or offering out there. But it's also a little bit confusing, and I don't think I've done a good enough job at explaining it. So I will hopefully clarify that through a case study today. But before I get to that, the updates we've given are, so it's now under GASLA. Each domain can now have up to 100,000 topics within a domain. You can have up to 100 domains within your Azure subscription. So that basically means you can have 1 to 2 domains per Azure region you're operating in. And you can have 50 Firehose event subscriptions at the domain scope. And I'll explain that in a moment. So what is an event domain? An event domain is really just a management construct. It's a bundling of topics that give you a couple benefits. So the first one is that you can manage all of your topics in one place. So an event domain allows you to essentially bundle your topics together so that when you have, I don't know if any of you have more than, let's say, 10 to 20 topics that you're using in production, but once you get past that number, unless you are very disciplined with your naming schemes and your use of resource groups, it becomes incredibly unwieldy very quickly. A domain allows you to basically put all of your topics under a given construct and then actually manage them using role-based access, which is the second part of it. So you can set fine-grain auth per topic. So you can say, Contoso user 1 has access to my domain topic number 1, and you just set that as a role-based check, and then you don't even have to actually provision the topic. That customer, as soon as the first subscription is created for that topic, we go and generate that topic, and your events will start to flow through. And you can set exactly who has access to subscribing to which topics. And then the third thing it gives you is a single endpoint to publish all of your events to. So let's say you have a scenario in which you have internal and external customers, and you don't want to manage 2 topics. Just in this simplified scenario, you can publish all of your events to one domain endpoint, and then within that domain, when you publish those events to the domain endpoint, you assign within each event which topic it belongs to in the topic field of the event itself. And then we will manage sending those to the right topics. And then you give your internal users and your external users access to only subscribing to the topic that you want them to have access to. And then we're going to manage the publishing of those events to your internal and external users. So to try and clarify this a little bit, actually, I'm going to do a case study of something we actually implemented internally within Azure, where domains have actually kind of enabled us to build what I would guess is one of probably the more complex eventing systems. Within Azure, we have Azure Resource Manager that I'm sure you're all familiar with. And Azure Resource Manager is kind of the universal control plane for Azure. And as such, it needs to be able to send events and notifications and data to all of the Azure services. Not only that, but Azure services are built on a regional model for the most part. And so Azure Resource Manager needs to send events to each service within each region. And so when you start to multiply that out, it becomes a massive number of events and notifications that Azure Resource Manager is sending out to all of the services in every region. Trying to reliably do this becomes quite painful, especially if, let's say, my storage service and my service bus service aren't supposed to be listening to the same events all the time, or one of them has an outage. How am I going to keep up with it or not block my other service? So Event Grid basically allows you to create what we call an outbox model. So putting in a domain between Azure Resource Manager and all of the services basically allows Azure Resource Manager to publish all of its events to a single place, and then at setup time they just define which resources are allowed to subscribe to what subset of events, and then the event domain now manages the authentication of each of those services, who can subscribe to what, and the reliable delivery of those events to every single service. On top of that, this is kind of where the integration with event hubs comes in, is a BYO inbox. So if the event domain is your outbox and is basically managing the publishing of the events outward to all of these services, each service can actually bring its own inbox type that is any of the natively supported Event Grid event handlers, and can manage those events on their own with their own model. And what this actually allows is also a event sourcing pattern. You can also imagine an event sourcing pattern. So let's say it's not just the Azure Resource Manager that needs to publish events out, but actually every single service within Azure, and this is actually the case, needs to be able to stay in communication with the other services. Each one can have its own outbox and event domain, and then each one can have its own inbox. So if each service has an event hub as its inbox and then subscribes to multiple event domains to that inbox, you now have an event sourcing pattern for all of the changes going on in this massively complex system that is the Azure service ecosystem. So going back here, each service has an outbox and it's publishing to the inbox of every other service. And then on the other end, each service has an outbox and is publishing to the inbox of any service that's interested. And so what you now have here is a highly connected web of all of your services, but there's no central, we've broken away from a hub and spoke model where Azure Resource Manager needs to sit in the middle, and instead each service, because it has an outbox, you could imagine that Service Bus, for example, here could actually subscribe to the storage outbox on its own and loosely couple the entire system. And it can subscribe only to the events that it's interested in. So that's hopefully maybe a little bit too overblown of a case study, but that's actually somewhere where we're using event domains in our own services in a live production environment that has significantly improved our efficiency and is allowing for all sorts of really cool new features to be built on top of it. That's kind of the inboxing, outboxing sort of thought with event domains. If an event hub is your inbox, then an event domain is your outbox when you have multiple potentially unrelated actors that need to subscribe, and you need to control each one. So what's coming next for Event Grid? Unfortunately, I can't share specifics of our roadmap in a non-NDA environment, but I can kind of give you a general idea of what we're aiming for in the next 6 months to a year. So the first thing that I really want to be working on from a high level is removing workarounds. So Event Grid is now at the point where its performance is generally smooth enough, and it has a lot of the capabilities that we were hoping for when we first set out. However, there's a lot of little places where there's workarounds. Things like if I want to publish events to something within a VNet, I have to put a storage queue as an intermediary, because storage queue has VNet integration and has rules that allow for inbound from Event Grid. Or if I want to publish events to a function and I have multiple functions and I want to change those keys, I have to either do that manually or I have to roll my own service to go roll those keys on the functions endpoint that I'm publishing to. There's a lot of little things in there that make it functional if you do the workarounds, but they're not clean, they're not perfect. And so that's kind of cleaning house on those areas is one of our big priorities in the next 6 months. And so please do kind of be active in the forums, whether it's documentation or user voice or Stack Overflow or anywhere else, to give us feedback on those areas that you do see major workarounds that you're doing all the time. Because if it's something you do every time you set up an event subscription in EventGrid, it's something you shouldn't need to be doing more than likely. The second thing is greater transparency. So one of the biggest pieces of feedback we've received, and I fully agree with it, is that EventGrid, when it's working properly, all hunky-dory, you can kind of set it and forget it. If you start seeing failures and retries, there's not enough visibility into what's happening, into what specific event is failing, where it is, like the event ID. We don't really expose event level logs, things like that. So making it easier to diagnose and debug and see your entire end-to-end eventing infrastructure is another big area of focus for us. And the third one is cloud events. So those of you who know Clemens Vassars, if you go log on to the cloud events GitHub repository, he's still the single biggest contributor to that effort. But you can also see there's actually been a lot more interest from folks. Google's always been interested. AWS actually started making a couple posts. Everyone under the sun is more and more interested in. And there's a lot of PRs on the v0.3 tag. So we're still very actively involved in this effort, and we're very excited. I can't wait for cloud events to hit 1.0, because with the amount of attention it's starting to garner amongst the large cloud providers, I think a widespread adoption is quite possible and could actually make everyone's life easier, whether it's hybrid or multi-cloud or hybrid or any other sort of third-party integrations. So lastly, I just want to give a really quick demo kind of demonstrating, based on that future direction, the sort of thing that I want to make into a 1 to 2, maybe 3, 4 click process. So I just have a quick demo of using a blob event to trigger, using EventGrid, a PowerShell Azure function, which if you haven't used, it's in preview right now. And I'll be honest, I'm a Bash guy. I don't really use PowerShell that much, but it's really awesome. The PowerShell functions preview is super powerful and makes a lot of things very easy. And it will, this demo will pretty much just instantly spin up an Azure container instance. So I have my resource group here, and what we're going to do is we're going to connect my Azure function with an event subscription to this storage account. So I actually already have that set up. When you come over to the Events tab in your storage blade, you can see the various event subscriptions I have here. This one is just using a blob created event. If I go to filters, you can see I'm just using I'm filtered down to just blob created. And so I'm just going to drop a image in here, and it will kick off my Azure function. So let me go ahead and do that really quickly. Navigate to my image store, click upload, and then select a file to upload. Favorite pizzas. It's always important to back that up. And so what we're doing here, it's a super simple Azure function. I'm just kind of pulling the file name out of the URL, and also appending to that the event ID to make it unique, so that I always have a unique container instance name. And then I'm just spinning up a super simple container instance. And the really cool thing here that kind of made me excited about this is within, I don't know if you've used managed identities within Azure Functions, but essentially you just toggle this, and now this Azure function has a managed identity. And so I can now give it role-based controls within my resource group. So I've given it permission to just create container instances. And so if I go back to my resource group and refresh it, I have a new container instance called Favorite Pizzas. And that took almost no lines of code and a couple clicks. What I want, though, the whole idea of showing this is, in theory, this should be, really a point and click. I have this image that does this simple process on a blob or whatever else it is, and I should be able to come into the Azure portal, do 3 or 4 clicks, and I shouldn't have to worry about the gunk that goes in between connecting everything, and just point my storage container at my my blob container at my container image, and everything should just start running. So that's kind of the vision. We're working towards that today. So that's all I have for you guys. So thank you very much. I think we have 2 or 3 minutes for questions if anyone has any. And I do want to remind you guys, please do stay in touch via commenting on docs and blogs. If you're an MVP, use the Azure Advisors Yammer, feedback.azure.com, Stack Overflow, we have Azure-Event Grid, or you can email us at askgrid@microsoft.com. So thank you very much.
Covey.co